first question, if you know me, you probably know this talk. Yeah. So why are you here? Okay, so you who tried Kotlin then? Like some. What do you think of it? Just yeah, everything is great. That's it. Okay, who wanted but didn't have the the resource, the reasons, the problems to convince your boss to try it? There are some people. Okay, that happens as well. Okay, so I'm sorry that there is high chance you saw this talk. But on the other hand, at the end of the talk, we'll have, oops, there's quite a big step, yeah. So at the end of the talk, we'll see the most difficult feature of Kotlin from my point of view. What is it? Who knows? The most difficult feature of Kotlin. You know Kotlin, everyone. Everyone knows here Kotlin. Please, Okay, so that's great. You know this talk, but you don't know what it has for you at the end, so we can start. I'll try to do the first part as fast as possible to not step too long for this in this introduction. So, for those of you who haven't tried Kotlin already, are there some who hadn't tried it? Okay, so be focused in this introduction section. So let's start. Kotlin is a language, and here there's 3 buzzwords about Kotlin that are true for lots of languages. And of course they're just buzzwords, but for me they have this special meaning. So this is our agenda for today. We'll talk about why Kotlin is modern, why Kotlin is pragmatic, and why it's so Android-friendly compared to maybe some other nice JVM languages. Let's start with more pragmatic issues and leave this buzzword modern to the end of the talk. So it's from JetBrains, as you know. So you can expect really good tooling for that. So JetBrains is the creator of IntelliJ IDEA, and you can expect having all this IDE support for Kotlin from scratch. So everything you used to have for a Java language should work for Kotlin as well. Another aspect of Kotlin being a pragmatic language is that it can be very easily mixed with Java code. So the Kotlin code is compiled to Java bytecode, and then it can be converted to Android format. That means that you can easily use your Android applications in Kotlin. But there is an interesting aspect, because you see, it's not usually very difficult to call Java code from every JVM language, like Scala, Groovy, whatsoever, everything. But if we're looking on what's going on vice versa, what if we try to call our new language from Java code? That might be some problems. And for Kotlin, that's not an issue, and so you can easily call Kotlin code from your Java code. And that happens because it's one of our greatest priorities. So we created Kotlin to be easily mixed with Java code. We'll see some examples later. Okay, then the next one. Why it's so Android-friendly? At first, as you know, Android Studio is based on IntelliJ. That means that you have all this feature support, IDE support, for Android Studio just for free. So you just install Kotlin compiler and that works. Speaking about the size, it can be compared to not a small library that you have to add to your project. And that's not very big. And what's interesting as well is that there is no such thing as Kotlin SDK. So we do not have our own library, our own standard library. We do not re-implement all the collections and other stuff. So we just use Java standard library, JDK, and add to it a bunch of useful extensions. And this is the reason why at first we have a rather small runtime, jar that you have to add to your project. In Android, in the case of Android, it's text file. And on the other hand, you have really a very easy Java interop, because you see, you use the same collections. So you do not have to convert it every time when you use Java code from Kotlin and vice versa. So, because of that, you see that this library, this Kotlin standard library, it just consists of a bunch of extensions. And another thing that means is that if you use not all of them, ProGuard will cut a high percentage out. So that's good as well. Who is using Kotlin now? I've added this slide recently. I just checked Kotlin's site and found out that there are plenty of companies and plenty of Android applications that use Kotlin. And you see, you can be one of them, despite of all your reasons. So now there is our next big topic. So maybe there are some questions for what I have said already. Questions? Later. Okay, we'll do questions later, as you would. So this thing about being a modern language. For me, it consists of 3 parts. You can see them. And it's our agenda for the rest of the talk. So we'll discuss each of these, again, buzzwords in detail. What do I mean by that? And the thing that you should keep in mind is that, of course, we can't see all this thing for every language. But for us, it's important to compare Kotlin with Java mostly. So we can say that Kotlin is more concise than Java, safer than Java, and more expressive than Java. So we do not interested in this in absolute terms, but mostly in comparison. First, concise. So there is a classical example of why people want to use these modern languages instead of classical regular Java 1. There is a class that actually do nothing, just stores the data, and it is very verbose. So we would like to express the same concept in a much shorter, in a much concise way. And this is not the feature of Kotlin. So many other modern languages do the same thing. That's important. And I'll show you it from the example of automatic tool that can help you to learn Kotlin and to use Kotlin in your code base. So this is an automatic converter from Java to Kotlin that you can use on any Java file, and it produces the Kotlin file, the Kotlin code. So in this case, the Kotlin version of the example above will be much simpler and much concise. And actually, under the hood of this declaration, just the same things are hidden. So this code will generate absolutely the same code as we see before. So like class, two fields, a constructor, and two getters. In Kotlin, we do not work with fields directly, we work with properties. But anyway, this looks much more easy to read and understand. And it is a notion that is similar to most of the modern languages, not just Kotlin. So it's not a Kotlin invention whatsoever. In this, to improve this example, you can add one modifier, data, and this modifier will generate a bunch of useful methods for the person class for you, like equals, hashcode, toString, and some others. Okay, now let's talk about safety. What I'm going to talk here about, who knows? Yes, nulls, null. Please be fast with nulls. We know everything already. Okay, I'll be fast. So there is can be a problem. In Android, the Android case, this will be your app crashed. Sorry for that. No, sorry, just crashed. So what's the problem? There is an error occurred, and we do not have don't know what's happened what's really caused. And if we press details, it shows us no extra information what caused that. And several years ago, there Svetlana Isakova, who invented this term, who invented null reference, suggested to call this problem $1 billion mistake, because we can't just count how much money we spent on fixing these null pointer exceptions. And the modern approach is to make this error, this null pointer exception, a compile time error, not runtime error. So we want to prevent this when we write our code, when we compile it, but not to have this exception at runtime. Again, this approach is not Kotlin specific, so many languages do the same. For example, what's the approach of Java 8 for this problem? Option types, yes. And for Kotlin, as well as for Swift, who is familiar with the Swift language? Okay, some of you. So you know this concept already. It's nullable types, so it's the similar concept. And I will quickly explain it to you for those who maybe are not familiar with it. So in Kotlin, we distinguish between regular types and nullable types. If you declare a type without question mark as a regular type, it means that the variable of this type cannot contain null reference. If you use question mark, that means that you can store null in this variable, the variable of this type. So imagine we want to dereference it. We want to call length on S1. Is it correct? Yes, it's surely correct. Nothing can be broken because it can't contain null. And as for the second example, yes, it doesn't compile because it can throw null pointer exception at runtime. So Kotlin provides us a nice tools to cope with null pointer exceptions, with nullable types, I'm sorry, and here they are. So what you can do with a variable of nullable type. At first, you can check it for being non-null explicitly, and then use it as a variable of non-nullable type. And the compiler will compile this code. But in Kotlin, you can do better. And to simplify this code to just this concept, it is called safe access. Who's familiar with that? Okay, so some of you knows it. So what's going on? If S is null, then null is returned as the result of the whole expression. If S is not null, then the length is computed. So it's the more concise way to express the same concept that we saw before. This is called safe access operator, and the result type of this expression will be nullable. You can provide the default value if you want. So in this case, you say, if this expression is null, please return 0. And this is called else operator, and it helps us to simplify our code as well. So if you're familiar with Groovy, you see that there does the same operators. So it's not the concept that Kotlin invented. It was known before. You can check for being null explicitly and throw an exception, or call the function that throws an exception. And then you as well can access this variable as having no null type. And of course, if you want, you can throw null pointer exception. But in the case of Kotlin, you have to do that explicitly. You have to put these exclamation marks, and that means throw null pointer exception if it's null. So for Swift language, who knows how do they express the same concept? Yes. So there is the Swift language, and there they have one exclamation mark for this thing, and in Kotlin we have two, just to say, please try to avoid doing that. So you'd better use safe operators, and do not use try to avoid null pointer exceptions in your code. But if you have to do that, you can. So there is an interesting question. What about the performance? Because you see, you as Android developers are very interested in the good performance for your application. So how these nullable types can be implemented under the hood? One solution would be, as for option types, some wrappers. But if they were wrappers, then you would create an extra object for every nullable type. That would be terrible. And in Kotlin, that's not the case. So in Kotlin, we use just annotation, no special annotations. And at runtime, there is no wrappers. There are no wrappers. It's just the same types. And all these annotations are checked at compile time. That's quite good for Android. Okay, let's move to the last time of my talk. This is the most complicated thing. Kotlin being expressive language. So what do we mean by an expressiveness in a language? I would say that it's all about being able to write better code, to create more abstract solutions, to be able to write nicer code. And I will cover 3 features that help us enormously to do this in Kotlin. And this will be my agenda for the rest of the talk. These 3 features: extension functions, lambdas, and at last lambdas with the receivers. So let's start with the first one, extension functions. Who is already familiar with this concept in different languages? Okay, some of you. So you can be familiar with it, for example, if you know C#, or if you looked at Kotlin. Yes, surely. So what does it mean? In Kotlin, you can create an extension to a class. So in this example, an extension to a string class. There is a regular solution that, so say you have a library class, but it misses lots of nice utility methods that you would like to add to it. And what is the regular solution in Java? You just create a special util class with lots of static methods that takes this string as a first argument, and you use them from your code. In Kotlin, you can do better. You can declare this as extension function, like in this example, and use this reference as string. So use string as this in the body of the function. And you, as usual for this, you can omit it, and you have like this. So there is extension functions, and in the body of this function, there is implicit this that refers to the class. So to some extent, it's very similar to Java's standard approach of having static function that just uses this receiver as the first parameter. However, having extension functions is more readable. So when you write the code that uses these util functions, it's much clearer what's going on if you have it like this, like class char on string. And these functions are visible in completion. So you do not have to go to this util class with all these static members trying to find what you actually want. You just invoke completion and choose one that you need. And it can filter them by type as well. Okay, so now I have a question to you. What do you think? Is it possible to call private members of string from extension function? So I will, at first I will show you the next slide, and just keep this question in mind. Whether it's possible or not to call private member of string from the extension function, from last char. So the next slide that will help you to answer this question, and then we'll turn to that. So, as I told, I forgot to say that in Kotlin you have to import these extension functions explicitly. You just can't declare them in one place and use afterwards it at any place in your project. You have to declare to import these extensions explicitly to not to have very dirty code without understanding what all these extensions go from. So, as I told in the beginning, it is very easy to mix Kotlin code with the Java code. So you should ask at this point, how should I call this extension function from Java? And the answer is quite simple, as usual, as you usually do. You just call, so last char compiled to a regular static function, taking string as the first parameter. So from Kotlin, you call it from a special class that contains this static function. And you can add a static import in Java to simplify what you have. But anyway, it's a regular Java pattern, so it's easy. It's very easy. So returning to my question, is it possible to call private members of string from the extension function? Who thinks that's possible? Who thinks that's not possible? Why? Yeah, it would work because it's just a static function. So you see, is it possible to call private members of string from a regular static function? No, that's it. It's not possible. The compiler forbids that. Private members can be called only from the class. And the fact that static functions are compiled to, extension functions in Kotlin are compiled to regular static function in Java explains that you cannot call private member of string as well. Okay, then I'll show you some examples that are specific for Android. So here you see the regular toast, and in Kotlin you can write it in a much easier form. And why it's possible actually? You see that of course you can hide this length short argument, but it's interesting that this reference is hidden because this toast is declared as extension function on activity. So because it's declared as extension, you can call it on this reference on activity, and as usual for this, you can omit it. So you have this very short code. So there is no much magic. There is just an extension function that delegates this call to regular make test function. Another example. The way that you start a new activity by creating an intent, it's a common pattern for very simple cases. You can rewrite it to Kotlin like this. And again, this start activity function is an extension function, and it can be called on this in the context of activity, and you can omit this reference, and you have simpler code. Surprisingly, this to function is an extension function as well. So it's not a special construct. It's just a generic extension function that can be called in a special infix form. So we write infix operator, infix function, and under the hood is just an extension function as well. So you see that extensions is a very powerful mechanism how to make your code more clear, more nice, and so on, more expressive. Okay, now let's move on and look at another feature I wanted to show you as a thing that makes Kotlin really expressive language, and that Lambdas. So who knows Lambdas already? Sir, some of you know. Basically, you can think of Lambda as another form of anonymous class. So in Java, to set onClick listener, you create an anonymous class that extends from this onClick listener, and you implement the the method there. And Lambda provides you a shorter way to do this. So the only meaningful code is what you do on click. So you can put it in a Lambda, and again, this code looks more concise. But Lambdas can be very powerful not only when you need an anonymous class, but also, for example, when you want to manipulate collections. That's the whole topic. There are many books about how to manipulate collections with Lambdas, for the examples from Java Age, for the examples from Scala, etc., etc. And it goes from functional programming. If you're not familiar with it, you might be interested and to go deeper. What this syntax means. So basically, in this example, I have employees. Employees is a list of employees. And I'm interested in the average age of employees that work, for example, in Prague. So JetBrains has a very small office in Prague, and I might be interested in that. So what should I do? At first, so I can write this code in a very concise manner. I can filter and leave only employees that work in Prague. Then I will map the list of employees to the list of their ages, and at the end I will count average. So this code looks very concise, and in Kotlin there is Lambda, and the full form of the Lambda will be has employee as an argument to the function and return the predicate whether it lives in Prague or not. The same thing with age, has employee and return its age. So it is just a placeholder. It's a name for Lambda arguments if there is only one argument. And so you can do this. You can write such code in Kotlin. That's really beneficial. It simplifies lots of our code, lots of our manipulation with collections and so on. But then you might ask, okay, I can do that, but you can actually write this code by hand, and maybe it will have the better performance, because you see there is Lambda. If for any Lambda means an anonymous class, then for this short and small operation, you'll have to create 2 anonymous classes. That's not good, yes? It would be not so beneficial to have such performance for your Android code. So actually, that's not what happens. Under the hood, these Lambdas, for the collections example, can be inlined. That means that no anonymous classes will be created. Lambda code will be just substituted directly in the function with this invocation. And you won't have performance overhead. So of course it can't be done for every Lambda. So for example, in the set on click listener example, anonymous class should be created because this method expects the instance of this on click listener. We can do nothing about that. But for the case of Lambdas, this code can be inlined, so you'll have good performance. Okay, then we are ready to my last feature. This is Lambda with receiver. So who has an idea of what it is? Okay, then it might be interesting for you. So basically, it's very simple. You see, there is a first concept extension function. So I think now you more or less understand what it means. Yeah? Okay, another thing, Lambdas. So mix these concepts together and you have this Lambdas with receiver. Who now thinks that it's very clear? Okay, let's look at some examples. From my point of view, this one is the most difficult, the most complicated feature in Kotlin, but it gives us a lot of power. It helps us to create these cells, to create very good APIs and so on. So let's investigate what's hidden. So let's start with this rather simple example. You create a string builder, then you append a string there, then you append characters there, then you return the result. Yeah, so that's very clear. What's not so good with this code? You see, the string builder variable is repeated for several times. Of course, it's not so bad if it's like 2 letters, but in a real program it will be string builder, or maybe string builder something else. So we would like to avoid that, to simplify that. And Kotlin gives us a way to do that. You can use with, and you see that in this example, with is, you see this variable now is repeated only once, and in the body of this with, you can use it, you can call all these methods without explicitly specifying. So I would say this should be clear, yeah? Okay, and then the most interesting thing on this slide is its heading. You see, in Kotlin, with is a function. It's not a building construct into the language, like in Python, for example. It's a standard library function that allows you to do that. So it's not a special construct. So how it works? Lambda is receiver should be used here, I'm sure. So, okay, with is a function. So why it looks like a built-in construct? Lambda in Kotlin, as you saw in the previous examples, always goes in curly braces. And actually, these curly braces is lambda. And this lambda is a second argument to with function invocation. In Kotlin, we have the agreement, the syntactic agreement, that if lambda is the last argument, then you can move it out of the parentheses. So another way to express the same concept will be put lambda, the second argument lambda, explicitly as a second argument. So in this syntax, it's clear what's going on. With is a function, string builder is the first argument, lambda is the second one. Yes? So, but Kotlin allows us to express this function invocation in a nicer manner by very simple syntactic convention. Okay, and then this is an implicit receiver in this lambda. So, do you remember that we have these extension functions, and in the body of extension function, this is hidden. This refers to string. And in this case, the same thing happens. There is a lambda, a regular lambda, but inside the body of this lambda, this is hidden, and this is an implicit reference to a receiver. In this case, string builder, but it can be differently expressed. So, in this case, you use this reference written explicitly, but again, you can omit them, and you'll see the same example as we had before. For very curious, I will show you the declaration of it, but it's a generic function. It's a rather complicated thing, but the main thing is that it has 2 arguments, and the first argument is a receiver, string builder, in the example before, and the second argument is lambda with receiver. So here how we express this type, but the types are not what interests us here. So the main thing is these 2 arguments, and we just call this variable of a function type, this lambda, on a receiver. And in the example, we have this string builder lambda, and we just call the code in lambda on string builder. And that's how it becomes this inside it, and everything happens, and everything works. Okay. I will show you another example from a very nice talk about Android, and this example shows us how we can avoid duplication in our code. So you see there is a pattern. You create a connection, then you should begin transaction, end transaction, and do it in a try-finally block. And what differs from one example, similar example to the other, is this delete functionality. And what we can do, we can extract this functionality in a Lambda. And this looks much more concise and clear what's going on here. And again, there is a question whether, what about performance? So you see there is this example, and if we have to create an anonymous class for every Lambda, this would be terrible, because you will have to, so the performance would suffer in this case. And that's not what happens. As I've told you already, we can inline the code of the Lambdas, and there is no performance overhead. And what that means for this example, when you write in transaction, the code that is generated is similar to what you would write by hand. That's what's that what makes this approach very powerful. I'll show you 2 more examples with this approach from Anki library. It's a DSL, domain-specific language, for creating layouts dynamically. So regularly, you just define them in XML files. You can create layouts dynamically in Java, but that looks terrible. You have to initialize every object, then to set the parameters and so on. And in Kotlin, you can do better. You can basically write the very similar to things that look very similar to your XML. However, you write them in code. So I would say that this example should be very clear and easy to understand, because it just creates this layout, and you write explicitly what's here. It's title, message, and 2 buttons. That's great. But an interesting thing here is how it works. And actually, these curly braces are Lambda with receiver. So, and in this Lambda with receivers, a special receiver is hidden on which you can call positive button and negative button. So you see that this general concept allows you to do really very nice things. Another very similar example, these custom layouts, and again, a lot of Lambdas with receivers are hidden here in this code, and again, it's easy to read because it corresponds directly what you see in the screen. Okay, I hope I have 2 more minutes, and I have a bonus that was not at the beginning announced. It's Kotlin Android extensions. Who's familiar with that feature? Okay, then some of you are not. So what's it? It's a special plugin that you can download and install, and it is Kotlin way to solve the problem with find view by ID. So we would like to avoid having find view by ID in our code all the time. So we just create a special. So in Kotlin you can just use it directly. So say you declared a view with the ID, and in Kotlin code, you can call it by the ID, and it will have the type is declared button. You have to import this explicitly, so there is it works like an extension property. But the thing is that it's the view, so you do not have to duplicate the code or do something special. How it works under the hood, a bit of under the hood. So actually, the compiler generates the cache that stores all these views by the IDs, and when you call this view, well, when you mention it in the code, the Kotlin compiler will get this view by ID as a regular thing, and then stores this in this map. So if you do not access this view, it won't be stored in the map. And this code in the blue is generated by the Kotlin compiler, so you just use it, and you don't have to like work with the cache directly. And there is a famous, very common question: what's if my view is nullable? So actually, you can interpret it as nullable if you want. So if you want, you can like use safe access. You remember it means if it's null, set and click listener. Or sorry, if it's not null, set and click listener. If it's null, do nothing. Okay, I think I'll almost there. So now I'll show you some links, Kotlin links, and then. So there's Kotlin side. If you want to play with Kotlin, to try it, to do it, you can do it online. You do not have to install a plugin. And there is a series of exercises. They are called Kotlin koans. You can do that in the website online or in a plugin of IDEA plugin. We have now a special educational edition plugin that allows you to do that. Who maybe someone tried them? Look us, oh great. There were some of you who tried. So now we have more ways to do that. And yes, you can tweet if you're successful with that, like, I've passed the class. As was mentioned in the beginning, there is a book. There is now my project, my main project for today. There is a book about Kotlin. We are not finished it, but you can buy it already. Yeah. And there is a discount code. It's permanent code on the site, so you do not have to picture it. You just have to know that it exists. So we have a community in Kotlin Lang Slack. So maybe someone is there. Where is this? You should say yes, we are. So if you want, you can join. There is active discussion, what can be done and how. So thank you very much for your attention and have a nice Kotlin.
Questions?
Hello. Hi. By your recommendation, what would be the best way to see generated Java code under the Kotlin?
Generated Java, so you can see bytecode easily. So there is show bytecode view, and then you have to somehow decompile it. So you see, Kotlin, there is no Java code generated from Kotlin code because it is compiled to bytecode. So you can just investigate what's going on by looking at bytecode and trying to decompile it. So now recently, a colleague of mine prepared, Dmitry Zhemerov, who is actually co-author of the book, he prepared a talk, what is hidden under different Kotlin constructs. And he will just show examples of what we had in Kotlin and what we have in Java, the similar code. So I would say that it might be the easiest way, and another way will be to decompile it explicitly.
Thank you.
Yeah? Yeah? Okay.
I have heard that some rumors about JetBrains making a static analysis tool or a set of rules for Kotlin specifically. When is the timeline of that?
I don't know. There is lots of static analysis is built in IntelliJ already. So all these inspections, all these things like and annotation processing as well, and lots of static analysis is built in Kotlin compiler. So there is no, and some of other are built in plugin. So there is no an extra tool. It's just we do some static analysis. So for example, several years ago, I implemented this static analysis for variables. So if your variable is initialized or not in the Kotlin compiler, and it just built in things. So there is no extra tool. Yeah.
Okay, so Lambdas are obviously a very useful feature, and they are one feature that was originally in some functional languages. So
Yes.
I was wondering, are you planning on adding some additional functional language features in the future, or is it in discussion, like maybe lazy evaluation, infinite lists, or first class functions as first class objects and stuff like that?
But all you mentioned, you have.
Oh well, I don't know Kotlin. I mean,
Okay,
is
so
it implemented
actually you have all these features and functions as first class citizen. It's just the thing that you can store Lambda in a variable. So you can do that.
Yeah, I didn't know that.
With, it's what it means. Another thing, we can have some extra support for function like tail recursion, but I would say that very, like it's a rare case.
Like, yeah,
and
lazy evaluation and
lazy,
stuff.
yes, we have. You can evaluate the property lazily. Yes, we have the support for that as well. So it wasn't just mentioned here. Yes. I would say we are maybe have to run away and give an opportunity for the next talk, but
Hi.
yes?
Is there support for integrating Kotlin with native code, something like JNI for Kotlin?
No, there is no specific thing, but I know some people who tried that, because so the general concept is that everything that works for Java should work for Kotlin. Except the tools that rely on source code. But most of things rely on bytecode, and in this case, they are just interchangeable. And the same thing, you can declare a function as external, and that. So okay, let's omit the details, but I know that it can be done. Yeah.
Thank you.
Okay. So we can, if you have any more questions, please